Hey everybody, we are on to 313, slopes of parallel and perpendicular lines. And you guys are going to love this because it is very different than what we did in 311 and 312. This is sort of a throwback to units 1 and 2, talking about slope-intercept form. So many of you are going to be like, yes, all right, here we go. As much as you can feel that way about a math lesson. In lesson 312, you learned how to label the vertices, the corners of an image, to show how those vertices correspond to vertices of the original figure. Today, you will learn about relationships between an object and its image that will help you to predict the image's position. These relationships are described using algebra and are just one example of a connection between the new geometric concepts you're studying and the math you've learned in previous courses. So basically, we're putting some geometry together with some algebra. At right triangle PQR was reflected across line L to form triangle P prime Q prime R prime. Describe the relationship of the original triangle and its image. So we can see that if we were to connect P and P prime, that the distance from P to the line of reflection is equal to the distance from P prime to the line of reflection. So we can say that the two triangles are the same distance from the line of reflection. We can also say that they are directly across from each other. And normally when we say that, we're talking about if we were to hold the paper so that the line of reflection was vertical. If we were to turn the paper like this and say, oh, one's on the left, one's on the right, and they're directly across from each other. And we also know that it's a rigid transformation. So we know that they have the same area and lengths and angles, right? Rigid transformation. None of those things change. Connections with algebra. In problem 325, you made some observations about a reflection. Slope can help reveal much more about such transformations. Begin by graphing the equation y equals 3/5 x minus 4. So first we're going to start with that. Minus 4 is our b, our y-intercept. And then 3/5 is our slope. So we would go up 1, 2, 3, right 1, 2, 3, 4, 5. We'd have 2 points. You do want to use a ruler on this if you have one available. If not, just use the straight edge of something that's not going to bend. It doesn't have to be a ruler because we're not measuring anything. So there's our y equals 3/5 x minus 4. It says translate the graph of 3/5 x minus 4 up 5 units. Use tracing paper if needed. Now you could copy that onto tracing paper or wax paper and then slide it up 5 units. We can also just slide the individual points up 5 units. So we've got a point here, 1, 2, 3, 4, 5. And this point, 1, 2, 3, 4, 5. If you graphed more than 2, each point you'd want to slide it up 5. And then we would say, okay, so this is our new line that has translated up 5 units. What's the result? So you'll notice it's parallel, meaning it has the same slope. So it's going to start with y equals 3/5 x. And now the y-intercept is 1, so plus 1. So you'll notice that the relationship, the original one was a minus 4 for b, and the new one is a plus 1 for b. They are parallel. And that means that they have the same slope. The number, in this case, the fraction, 3/5, is the same. How do their slopes compare? Oh, sorry, that was what I just did. Rotate y equals 3/5 x minus 4, 90 degrees clockwise about the origin. So if you were to rotate this thing 90 degrees clockwise, what you're saying is each individual point is going to sort of turn. Or, and this is a great one for tracing paper, where if you put a piece of tracing paper over the top and you hold on to it right at the origin and you trace the graph that's there and then physically rotate your tracing paper, this one's really good for that. What you would also get if you wanted to do it sort of the old-fashioned way, this one has an intercept of 1, 2, 3, 4, negative 4. If we were to rotate it 90 degrees clockwise, that intercept would move over here onto the x-axis instead of the y-axis. And then instead of going up 3, right 5, you'd kind of have to think of the paper as like moving and rotating. And you would go up 3, right 5. And you would have, right? Let me see. 1, yep. 1, 2, 3, 1, 2, 3, 4, 5. And you have your new point, or your new points, sorry, that make your line that's been rotated 90 degrees. And how do you know it's been rotated 90 degrees? You've got these 90-degree angles. Write the equation of the result. Now, what you just saw me do was rotate the paper to get that 90-degree angle. The slope was originally 3/5. The new slope, you'll notice, is going down, so it's negative, and it's down 5, right 3. So your new equation is y equals negative 5/3 x. And I will say, in order to find your y-intercept, which in this case you can see it kind of crosses in a funny place on the y-axis, you would have to do y equals negative 5/3 x plus b, and then pick a coordinate that's on that new line. The easiest coordinate to pick was the first one that we did, which is negative 4, 0. So you would plug in 0 for y, negative 5/3 x. Instead of the x, we're going to put in negative 4 and then plus b. And you would solve for b. You would multiply the negative 4 times the negative 5/3. It's a positive number. You'd subtract it from both sides, and you get negative 20/3 as your y-intercept. So you had a slope and you had a point. You substitute them both into slope-intercept form to get the missing b value. So what's the description? What happens when you rotate it 90 degrees? You get lines that are perpendicular. Perpendicular, meaning that they make a 90-degree angle to each other. They create that 90-degree angle. The original line and the rotated line are perpendicular because they form a 90-degree angle where they can intersect. Look at the slopes of the original line and the rotated line and make any observations you can. So the original line had a slope of 3/5. The perpendicular line had a slope of negative 5/3. So how can you, without going through the process of graphing the first line, rotating it 90 degrees, writing a new equation, how can you get from 3/5 to negative 5/3? The slopes are said to be opposite reciprocals. The first one was positive. The 90-degree, the perpendicular line, has a slope that's negative. The first one was 3/5. The reciprocal to that is 5/3. So the slopes are opposite reciprocals. And that is specific to perpendicular, okay? That's only going to be the case if you have two lines that are perpendicular. Just want to clarify that. When they were parallel, you notice you got 3/5 and 3/5. So parallel lines have the same slope, where perpendicular lines, the slopes are opposite reciprocals. Investigating slopes. Do you think that all perpendicular slopes are related in the way that you observed in problem 326? Investigate this idea by drawing 3 different lines with slope triangles on graph paper. Use slopes of 1, 1/3, and negative 3/4. So what we would want to do is, grab a blank piece of graph paper and explore some of these negative or opposite reciprocals. So I might do something like this and do a slope of 1. So if I have a slope of 1, right, this one has a slope of 1, I would say, what's the opposite reciprocal of 1? The opposite reciprocal of 1, so like 1 over 1, the opposite would be negative, and it would still be 1 over 1 when I flip it. So does the reciprocal, the opposite reciprocal, give you 2 lines that are at a 90-degree angle? Yes. So that one's an opposite reciprocal. All right, next one that they asked us to consider was something like 1/3. So if I graphed a line that had a slope of 1/3, so I'll put it on the origin, 1, 1, 2, 3, 1, 1, 2, 3. Our hypothesis, what we are proposing, is that if the other line had a slope that was the opposite reciprocal, so this one, m is 1/3, so the opposite reciprocal would be negative, and then it would flip to 3 over 1. So if we go negative 3, right 1, negative 3, right 1, and graph that, do we get a 90-degree angle? And we do. Last one that they've asked us to consider was negative 3/4. So if I graphed negative 3/4 as my slope. So -3, 1, 2, 3, 4. And I use this, it'll go up 1, 2, 3, left 1, 2, 3, 4. That way it kind of keeps it right in the middle. Also keeps it on my page. If I've got a slope, this one is -3/4. The hypothesis is that the opposite reciprocal of that should give us a 90-degree angle. So -3/4 is the one we were given. The opposite would be positive, and the reciprocal would be 4/3. So if we check 4, 1, 2, 3, 4 over 1, 2, 3, or we can go down 1, 2, 3, 4, left 1, 2, 3. That way we get points, again, that are all sort of centered around the origin. And do we get? Yes, we do. We get a 90-degree angle. So I think that's a pretty solid hypothesis. The question that's actually physically on the page says, what are the slopes of the new line? So the first one, if the original slope was 1, we're saying the opposite reciprocal would be -1. If the first one was 1/3, the opposite reciprocal was going to be -3/1, or just -3. And then the last one was -3/4, so the opposite reciprocal was +4/3. How does the slope of each rotated line compare to the slope of its original? We found that the change in y and the change of x switched. That's where the reciprocals come in, right? It was a 3/4, now it's a 4/3. And also that it went to the opposite signs. So opposite reciprocals. Use patterns from the work you've done to describe the general relationship of the slopes. It is a little redundant. The answer to this one is still opposite reciprocals. You can say that the change in y switches with the change in x, opposite signs. It still means opposite reciprocals. Slopes of perpendicular lines. Two lines are perpendicular when one line can be rotated 90 degrees onto the other. However, a rotation does not only move the points on the line, it moves all of the points and shapes on the graph. The axes do not move. Therefore, the relationship of the slopes of perpendicular lines can be demonstrated as true by rotating a non-special line with its slope triangle. So that's really fancy for when you turn it, it does not keep the same intercept necessarily. Like the ones that I did, the sample ones that I did, I put all of the intercepts right at the origin, and then I rotated it around the origin so they didn't move. But when we look at something like this, and you look at, say, this slope triangle, when it rotates, you're rotating around the origin. So your slope triangle moves over to here. It was sort of partially up the y-axis. Now it's partially down the x-axis. So the slope becomes that opposite reciprocal, but realize that the intercepts probably will change as well unless you have something going through the origin. A, use Sabrina's drawing to explain why the slope of the perpendicular line must always be -b over a. So what we did was we switched the horizontal and vertical segments. So you'll notice that the B was horizontal and now the B is vertical. The A was vertical and now the A is horizontal. So that's why it's the reciprocal part. And when we switch it, it goes from being positive to negative. So the horizontal and vertical segments switch and positive becomes negative. What if the original line has a slope of 0? Explain what happens to a line with a slope of 0 if it's rotated 90 degrees. Well, when you have a slope of 0, you have a horizontal line. So you have a line that's going side to side. So it has a run but no rise. So when you do rise over run, you're saying it has no rise. So your delta y, your change in y, was 0 on the original line. And now the delta x will be 0. Meaning you now have a vertical line instead of a horizontal line. So since you now can't divide by 0, your slope becomes undefined. So something that originally had a slope of 0, it becomes an undefined slope. And you can also say if the original was a slope of 0 and it was horizontal, now it's going to be vertical. Use what you learned about the slopes of parallel and perpendicular lines to write the equation of a line that would meet the criteria given below. Write the equation of the line that goes through point 0, -3, and is perpendicular to the line -2/5 x plus 6. So the first thing that's important is that it's perpendicular. So the slope of the line that's in the equation that we have right now is -2/5. So this is our original slope. The new slope has to be an opposite reciprocal to that. So the new slope has to be opposite. So it was negative, now it's positive, and reciprocal would be 5/2. So you're looking at something that's y equals 5/2 x plus b, and it's got to go through point 0, -3. So now I have something to substitute for x and y. So y is going to be -3 equals 5/2 x. And instead of x, we're going to put a 0 there, plus b. So 0 times 5/2 is just 0. And when I take away 0 from both sides, I get that -3 is the intercept. If you noticed, and some of you were probably rolling your eyes at the screen, -3, they gave us a point that was an intercept. But the reason I'm showing you out the work is because they don't always give you an intercept as that point. So you do need to be able to plug it in, 0 for x, -3 for y. That's the coordinate that they gave us. So the final answer is y equals 5/2 x minus 3, because that point is our new y-intercept. Write the equation of the line that is parallel to the line y equals 3/2 x plus 5, and it goes through point 0.7. Now again, they gave us the new b. They gave us an intercept. I'm still going to do the workout just so you can see it in case you were given a point that's not an intercept. So if it's parallel, it's got to have the same slope. So parallel line, same slope, still going to be 3/2. So my slope is 3/2. So I've got y equals 3/2 x plus b. Now, guys, we know it's 7. Just bear with me for a moment. Y is 7, x is 0. So you would do y7 equals 3/2 times 0 plus b. That's my x, 0, and my y7. 7 equals 0 plus b. If you take away 0 from both sides, you get that 7 is the intercept. So you'd say y equals 3/2 x plus 7. And that's because you will not always be given the y-intercept. Hopefully, people have some questions for me in class. Give some of the homework questions a try before coming to class, and that could really give you a good idea as to whether or not this made sense. See you soon.